me know, right? So yes, I started recording now. Yeah, thanks again. Excuse me. So what I was saying is C is a combined language. Excuse me. And that's the first main difference you'll see from Python to C. Python was mainly an interpreted language, so it runs through an interpreter. It's more like a scripting language, right? And one of the things you will see throughout this course is we make a very important distinction between, well, you are learning programming as a hobby, like anyone can go ahead and learn programming, compared to if you are learning programming as well as software engineering, right? So as an engineer, it's very important to know these concepts, to understand them. It's not just enough to be able to write some syntax of a language. Anyone can learn this, right? But you need to understand what really happens behind the scene. And I will try my best to make sure I convey this information to you, right? A good engineer, whether like software engineer or hardware engineer, it's very important to know these things, right? One of these things is to know whether a language is compiled or interpreted, and what is the difference between an interpreter and a compiler, right? Python was an interpreted language, which means it's, well, in other words, it's a script or scripting language. You don't have to compile to obtain an executable to be able to run the executable, right? In a later slide, we will have the full detail of the flow path of a C program. But in Python, simply you just write the code and then you run it through the Python environment, and then, well, it just runs, right? You don't do a separate step to obtain executable, and then later on you can take this executable and run it. For example, if you want to give your program to someone to use, not to modify or develop, you have to give, like in Python, you have to give either like a library encapsulating your code or the code itself. But you cannot give an executable, for example, right? In the form of like C executable, like an .exe, for example, right? Why that's the case? Because it's an interpreted language. If you have used MATLAB before, or most likely are going to use it as an engineer, MATLAB also is interpreted, so it's not a combined language. And there is a very big difference. We will see later on the detail of what we mean really by compiled, right? So we need a compiler. Yesterday we also went through this kind of compiler concept. We said it's covered in other courses in computer engineering curriculum, but simply a compiler will translate your high-level programming, like your C code, into a machine language, like zeros and ones, right? First translate into assembly, and then the assembly is translated into machine language. Well, like C is a very, very old language. It was developed in early 70s, and then many of the modern languages really build on top of it, including C++, Java even have some kind of very similar syntax and a lot of primitives from the C mindset. Well, if you might think, oh, this is a very old programming language, it's hard to learn, it's very low level. So, well, time has passed. C became very old, and right now Python and other languages like R or whatever might be the fancy one to learn. But that's really incorrect. C is still a very dominant programming language for some fields that would require, and that's another difference between Python and C. Because Python is an interpreted language, it's very slow to run. So if you want something to run in a very timely manner and it's like very computational intensive, C is the choice there. And this is the reason why many operating systems are really built using C, including the Unix kernel that is used in Linux and other operating systems as well, including the Mac OS. So because it's very low level, it's fast to run, right? That's why C can still be very preferred for performance reasons. It's also preferred for, as I said yesterday, for embedded systems, like something like automotive programming and the embedded software, because it provides low-level exposure to the programmer, where you can better control the hardware and know what is going on. So C is still very important, right? Well, that's a brief history of the different C standards. Well, we don't do something in this course that really differentiates between one standard and the other one. Most of the things we cover are really the basics of the language, which is like the same for all the standards. This is why I'm saying here, well, we'll study mostly the one of the oldest standards, like the C89, which still applies for all the modern ones, right? Well, C standard library, we will see later on what we mean by libraries and header files, but a good concept in programming languages, and you have seen this already in Python, is that there is already a pre-built code. Someone already developed so many powerful programs that you don't need to reinvent the wheel to use them. So you can just include them in your own program and make use of them, right? C, like the main programs in C, the main import, like import is not the correct word in C, but it's coming from the Python thing. Many of the functionalities that you can use in C that are pre-built are really encapsulated in the C standard library, which is a collection of existing functions that, well, you can handle the I/O, the screen, printing something on your screen, reading something from keyboard, some math calculations. We will make use of C standard library throughout the course. Now going to some of the interesting stuff. So here, well, if I want to print something in Python, Python is very easy. It's very high level. I just say print and then print whatever I want, right? In C, it's pretty much similar, but you need, because it's low level, you will find that you need to write more code usually, right? Because it's a very strict language and it has to have very clear definitions. For example, here, to do the same print, instead of using print, I'm using printf, and then I write it within parentheses, and then I have to, well, print here by default has a new line, but in C, well, you have to have /n for new line, and then you have to encapsulate this in a function, not a method, similar to Python. And this function has to have, as we would see later on, well, the return type of the function. In Python, you didn't have to define this. You can really return anything. And then the name of the function, which has to follow certain standard. Then what are the inputs? Here we don't have any inputs, so it's void. And because here I'm returning int, let me use a laser pointer. And here, because I'm returning an int, then at the end I'm saying return 0, right? Which means like, well, the program has succeeded, right? So if I quickly switch to an online compiler to just, well, let's have some hands-on. So later on in other lectures, I will be using the Eclipse such that to get you more familiar with the one that you are using in lab. But because I don't have my desktop working today, I will just use an online compiler. Where is this one? Yeah, here. So assume, for example, I want to print, welcome to sh4. Then I want a new line. This is how you would do it. What is include studio.h? Well, simply printf seems to be a function, right? To be able to use a function in C, you should be able to have a definition of this function and implementation. Later on, we will write our own functions and use them. But here we didn't have any implementation for printf. So you must wonder that this implementation is somewhere, right? Which is exactly inside this studio.h file. So studio.h is one of the, well, C standard library includes that you can use that has a definition of the printf, right? If I just run this one, well, you can just easily expect that this will come to 2sh, right? If I want to print few new lines, later on we'll have the exact syntax of the, well, maybe to better show it, I will print new lines between the words. You just see that every word is being printed in a line, right? What do we have here? That's the space, because also I printed a space after, well, 2sh, for example, has a space before between the new line and 2sh. The same thing for the 2. Good. You can try this really on your own, even if you didn't have Eclipse set up yet, because you didn't do lab 0. You can just open online GDB, select C, and do this while we talk. Good. Is there any question? Yeah, as I said, please make sure you include your questions, this question bracket, because otherwise I would have to read all this chat, which I cannot, right? And I don't think you prefer me reading your own chat as well. But why we didn't include void? So it doesn't really matter. If you don't want to have any input parameters, here you put the input parameters. If you don't have to put any input parameters, you can just leave it empty. If you put void, well, it's the same thing. So it doesn't really matter, right? Void really means no type. So you don't have an input parameter. Good. So going back here, well, some of the rules based on this example. The first thing is that every C program must contain a main function. So that's the minimal function that you have in your program. C is more like functional programming language, right? And why do we have to have a main? Because when you compile your code, have an executable, the first line that this program is being executed from is really the main starting point, right? So you can have so many files in your, later on we will see you have multiple files. In Lab 0, in fact, we have multiple files as well for testing, header files, and C code files. But you have to have one main and only one main, right? So you cannot have two mains and you cannot have none, right? It has to be only one main because that's the starting point of running the program. Well, I already explained the keyword int means I'm returning an integer, and 0 means, well, there was no error. The statement to be executed by the main is already included within this brackets, curly brackets, and that's the syntax of a function in C. So every function has to has this prototype line and then two curly brackets where you put your code in between. Good. More about this is also later on. And then we also explain that to be able to use the printf, well, the implementation is somewhere, which is, as we said, it's then stored.h, right? Another thing is main difference between Python and C code as well. C is very strict language. Every single line of code has to finish with a semicolon, right? Here in Python, we didn't really have that, right? So here you have to make sure of this. If you're not very used to having semicolons at the end of your code, well, you should get to, right? Well, here we are printing two lines using two calls for printf. Going back to the online GDB, I can just add another printf and put it. Maybe let me ask you a question. If I want to rewrite this program using only a single printf and I want to have exactly the same output, what can I do? Can someone volunteer to suggest something? You can use your mic for answering questions.
Hello.
Yep, please go ahead.
So you would use just one printf, but instead you would do principles of programming next line and then comp eng to us h4 next line.
Thank you so much. So yes, exactly. So having, well, printf, you can print anything you want in the format you want. Here, this is printing two things in two different lines, but I can do this only in a single printf, similar to what we have done in the online GDB. I did like welcome to sh4, everyone in a line, by putting new line in between. So new line does not have to be in the end. Thanks, Tina. Well, to write some comment in a C program, here also you find we have a comment at the very beginning saying printing two lines or whatever comment. Well, you have to use this, well, that's forward slash, like two forward slashes for a single line comment, or if you want a multi-line comment, you have to do it in that way, like a single forward slash and then an asterisk. Okay. So maybe I will show you a little bit from this as well. Going back to online GDB. So if I want to write a comment, I would say here I am printing, well, here. Okay. Well, 3 lines. As you can imagine, any comment wouldn't really being executed by the compiler. It does not get translated into a machine code, and it does not have any effect on the output, right? Another way of doing comments is here I am printing 3 lines, and then just do that, right? This is more like a paragraph comment, like you can have a multi-line comment between these two things, right? So commenting is a very good, I would say, behavior or approach in programming to get used to, because once you start developing more complex code, hell, this comment really means nothing at all. It's a single line of code, is self-explanatory, so that's really not needed, right? But when you write hundreds of lines of program code and you want different functions, different interactions, and you want to deliver this as a lab submission, for example, or to give it someone to use, or you're doing a project in industry, or even for your own use afterwards, after a couple of months, 3 months, you might forget what you have done. Using comments to explain your logic, like speak your mind to the reader of the code, is a very useful thing that you should get used to in programming. And well, if you read around while we do the labs and the lectures, I will emphasize this a little bit. But if you also read about it online, you'll find there are certain techniques to write very good comments. Later on in labs, we will be putting marks on good comments, right? So you will have a couple of marks, 3 marks, 4 marks that are dedicated to good explanation of your code, right? Is there any question? Okay, so I don't see questions. Okay, good. Well, okay, that's what we're explaining. And then let's try to write like another program. We want to write a simple program in C Python. I want to read an integer. Previously, we have printed something on the screen. Assume I want to read something from the user and then print something on the screen. So in Python, well, we use print to print something. We also have the input method to read something from the user. So I would say input, I give the user a message, and whatever the user inputs afterwards, I'm going to read into the num variable, right? Single line of code, very simple. In C, well, certain things you have to take care of. First of all, here this num is a variable. In C, any variable must be declared before used, right? And the type should be clearly identified. C is a strict language, it's not a scripting language, right? So, well, here you want to use a variable called num. You want it to be integer, for example, because you ask the user to input an integer. Then you have to define it to be integer first. So you have to say int num, and that's the definition of the number. Then this line of code in Python really is doing two things. The first one is reading, well, first one is asking the user to input something by printing something on the screen. The second thing is reading from the screen. So it's an output and input on the same line. In C, this has to be separated in two different functions. To output something, we have already seen that you should use printf for that. So you should printf enter an integer, but this is only telling the user something. It does not take any input from the user, right? So it just finishes in this line, as we have seen in like welcome to 2sh. Well, the program finishes. You don't ask the user to do anything. Then how to read input from the screen or from the user? We use a similar function to printf called scanf, right? Scanf will read something from the screen, from the keyboard, basically, and put it into a variable. Here, I wanted to put the input into the num variable. That's the num one. I will explain now what this and means, but that's effectively the num variable. And here, this is the format of the input that you need to read from the user. What do we mean by this? Scanf here is taking two inputs. The first input is the format that you want to read the input in. Well, %d is a reserved kind of identifier in C that tells I'm going to read the number as decimal, which is integer, basically, right? And then the second input is the variable that you want to store this input in, which is num, because this function is going to modify num, not just read it as an input parameter. Remember, we said here you put input parameters, right? Main didn't need any input parameters. Printf, its input parameter is the message itself, and it does not return anything. Scanf also does not return anything, and it takes two input parameters. Input parameter, well, by the name means it shouldn't be modified, right? But C has a way to modify the input parameters. How do I to change them inside the function by using this? Well, it's called pass by reference. We would have a separate lecture for this. But basically what it means is I'm passing this as an input parameter and I'm allowing the function to modify it. Good. So which means after the end of the scanf, the value that the user inputs in this format will be stored in the num. Good. So let's jump into the code, see it working, and then I will take questions if you have ones. Okay, so here, well, I want to say input input and here. And then I'm using scanf. The first one I'm defining that you should be like a decimal value, and there are a different identifier for strings, a different identifier for floats. We will see more about this later. And I want to take this in the num. But well, assume I'm just using num here and I didn't define it. I'll try to run. You'll get an error saying, well, error, num undeclared. First using this function because you are using a variable that you never declared, right? It's allowed in Python, but it's not allowed in C. Maybe I just do this to readable. Can I make it a little bit bigger as well? So here you have already seen this output message, right? If you are using a variable without defining it. So if I'm defining num here, and then let's say I'm just running it without adding this and, right? Let's see what happens. And let's say initially I inputted num to be 0, and then well, I'm just printing back the num value to see how it looks. Say num equal, and then well, I want to say that's also the num variable, and then I print num, right? Let me also print it before anything, right? Just to see that it's really equals 0. So what I do right now is I'm defining a variable called num. I'm assigning a value, initializing it to 0. I'm printing it. So what you should expect is num equals 0 here. Then ask the user to input something in this line, and then reading it into num. Well, we have done the mistake of not putting the and. We'll see what is the effect of this now. And then I'm printing the num after the modification. Good. So when I run that, oh, well, a very common mistake that you should guys have identified is I never added the semicolons, right? And then I run. Here you see, well, it gives you a warning. It's a warning, not an error, which means the program continues executing. But then it says, what is the warning? The format this, which is like identifier D, expects an argument of int asterisk, which is like a pointer, but it only gets an int. Forget about this warning for now. Its meaning is really saying, well, I cannot modify this, but let's just ignore it for now. Here I'm saying num equals 0. That's the first line. I didn't add a new line after it, which means the new message will print on the same line. That's another thing you should take care of. And then, well, you say, please input an integer. Assume I input here. The program is waiting for you to input something. So I'm just inputting 10. I inputted 10. And then, well, when I'm trying to print, well, it didn't really go to this line because the scanf didn't work as intended, right? Why? Because I'm passing a variable as an input parameter that I cannot modify, right? Just at the end, which means I'm giving the authority for the function scanf to modify the num. The correct wording is passed by reference. Let's see what happens. Let me also add a new line here, just simply to have it in the correct format. And then I run. If I do this like num equals 0, now you can notice the new line is better formatted. I do 10 and enter. Now it prints, well, num is being updated to 10, right? And it goes correctly. Right? Any question? Please make sure you put questions in brackets, otherwise I cannot easily scan, right? We will get used to this. What are other input types? We will go through some of this in detail. There are so many of them, and we will cover them in one of the slides. What does the and mean again? Ryan, I hope maybe when we did the example right now it's clear, but what it means simply is you pass this variable to the function as an input parameter, but also you allow the function to modify it. Otherwise, the function cannot modify it. Okay? Do you have to put include studio.h? Great. Let's see if I don't, not in every program, but when you use the functions from the studio.h, assume I commented this out, right? I didn't include it, and let's run. Here you get, well, it's a warning implicit declaration of this because it's already known. But in fact, if this compiler was more strict, it will tell you printf is not defined. Let's see if it gives it somewhere. It doesn't give it because printf is one of the most common functions. You just use it as a warning. But I believe, well, if you have a more strict compiler, it will tell you printf is not known. But the warning has the same meaning, which is implicit declaration of function printf, because you just use it here, well, and you didn't define it anywhere. Right? That's the main reason why we're using the include.h. Oh, I should stop the program because the program is waiting for something, and then I just modify. Good. If you didn't have a program that use anything from the studio.h, you don't have to include it. Why do we need to return 0? You need to return 0 because here main is saying I'm going to return an int, right? If I modify this to be void, which means I'm not returning anything, and just comment this line out, well, it should work fine, right? The reason for this is void means I'm not returning anything. In fact, printf does not return anything. This is the reason why we don't take the output in an input parameter, right? But because originally we said, I should stop the program also, because we said main is going to return int, we have to return something. Why it's a good practice to return int from a main? Because C has predefined error coding numbers, right? If the program didn't execute correctly, it will return something different than 0. So it is a convention that if you reach to the end line of the main and you return 0, means you had no error, right? This is why it's better to have int main instead of void main. Right? Can you go through why we need 3 printf statements? That's not really needed. I'm just being more, I would say, comprehensive now by, first of all, printing the original value of the num to show you that it was originally 0, to double check that, right? And then here, this is the necessary one because it asks the user to do something. And then here I'm reading the input from the user. And finally, I'm printing it to make sure num changes from 0 to 10, right? But that's, well, if you mean by needed is like mandatory for the program to work correctly, that's not correct, right? It's not really needed. I'm just showing it to walk you through what every line of code is doing. What is the significance of putting nothing in the main brackets? Is it the same as putting void there? Yes, well, it means I'm not passing any input parameters. In C, functions take input parameters and return values, a single value, and we will have the exact function syntax in a separate lecture for functions. But simply if it's empty, the input parameters, like, well, it means I take no input parameters, which is equivalent to void, right? What if we want to print 2 values in the same printf statement? Do we pass 2 parameters? Exact. That's a very good question. I believe I got disconnected for a second. Correct? I hope I'm back. Am I back? Can you please confirm that I'm back? Okay, thank you. Thanks everyone. So what I was saying is, let's try this suggestion out. Let's say I have 2 variables, num1 and num2, and then, well, I want to, you don't necessarily need to print them, but let's say num1 is equal that, and then num2 equal another output, and here I just pass num1 and num2. This is telling us that the syntax of printf is here you kind of format your output in the way you would like. It can be as many variables as you need, but printf in fact is very, very powerful in that sense. And the way it works is that it will fill in the gaps with the identifiers from the input parameters one by one. Here it means, for example, num1 will go to this identifier and num2 will go to this one, right? Let's try this one out. Oh, but to try it out, I guess maybe we should really have different because I don't have num. Should be num1 and num1 for now, but we don't care about this. So let's just give this a value of 10 and this is value of 20, such that we see the difference between them in the printf, right? And then if I run, You see here for this printf, num1 equal 10, which is the actual value of num1, and num2 equal 20, which is the actual value of num2. So the way printf knows this is like in the order format. The first input parameter goes to the first identifier, the second one goes to the second, and so on. Good. This was a good question. You cannot take out Borna, you cannot take out the identifier D because, well, this is the placeholder that tells the function that you are expecting an input parameter here. So if you take it out, it shouldn't take anything. So it will really complain about incorrect number of parameters, right? Good. Let's then go back to the slides back again. Oh, they just lose. Why they don't move? Let me see. Sorry, yes, that the slides hang. I should share the PowerPoint back again and then go full screen from there. Okay. Yeah, this is basically, well, let's say I want to read an integer and print its squared value, right? So maybe we can modify our example to do exactly that. So here, well, let's say, well, as a different example, because we have read already two numbers, so maybe please input. Let me say I ask the user to input 2, and so please input. I have to stop because it's still running, expecting some input. And please input 2 integers. Then here, well, I'm just expecting this, a space, and then this. And then I'm reading this into num1 and num2, right? Here, let's make this a little bit more comprehensive for the printf, saying, well, num1 is originally 10, num2 is originally 20, and num1 multiplied by num2 equals, and then I just multiply them and just say, well, it's another input parameter. And here, that's the good thing is you can not only put a variable, but you can really put a math expression, right? So you just multiply num1 by num2 here. So this printf, well, became a little bit more complex. You have 3 input parameters. The num1 goes to the first identifier. Num2 goes to the second one. That's an expression that evaluates to an int. Num1 multiplied by num2, in our case, it will be 200, and it will go to the third identifier. That's the original multiplication before the user inputs them. Then I ask the user to input 2 input parameters separated by a space. And then I will print back their multiplication value, right? Maybe even I print back exactly their values and their multiplication back again, right? Just to be more comprehensive. Let's see how these things go. Hopefully we didn't commit any mistake that the compiler is not happy about. Let's see. Originally num1 is 10, num2 is 20, and the multiplication is 200, and then goes to the second line, line 21. Please input 2 integers. I input, let's say 5 space 4, which is this syntax here in line 22, and then I do enter. And then here I go to this printf saying num1 is 5 because this one, the first identifier, the first input that the user gives goes to the first. It's the opposite of the printf. Printf goes to the first one, print it. Scanf reads the value and assign it to the first variable. So num1 gets to be 5, num2 is 4, and hence their multiplication is 20. Good. Questions? Okay, quick scanning. There's a question. What does it mean? And okay, so I kind of explained this identifier. %d means really you are expecting an input parameter in the format of digit or decimal or integer, basically, and we'll go through different possible identifiers later on. But simply here it means I'm Well, if you use it in printf, means you are going to, it's a placeholder, a template that tells later on I have a variable that I'm going to put its value here, and this variable has to be an int, right? If it's a scanf, that means the user has to input a decimal, or like in the correct type format of C. It's an integer value, right? Question: why did you write the num1 is 10 and num2 is 20? Well, just any value, any initial value. I'm not sure. Do you mean why these exact values? It can be anything, right? So just any initialization would be fine, right? In the first printf, when you identified num1 and num2, that there was a space between them, but why did you add and when identify? It doesn't really matter. It can be any format. Just to show you that you can really write the output in the format you would like. What would happen if num1 was an integer and num2 was a float? Well, you would have to use the correct float identifier for num2. We will show later on, but for now I just don't want to go to this detail. I don't want to confuse you. We have enough information in our program, but you have to use the correct identifier for the correct variable type. Okay, can you scroll up so we can see your code fully? Yeah, well, that's the full code, right? I initialize two variables. I print their values as well as the value of their multiplication. Then ask the user to input something. It's a simple printf statement that does not take any input. And then I read two variables from the user. And then finally, I printf the new variables that the user inputted along with their multiplication. And then I return 0 because here I'm expecting an int. I had to include studio.h because I make use of printf and scanf, which are only defined inside this header file. Good. What does having and num and un? Okay, so good. So this and seems to be confusing to you. Simply, we said those are input parameters, correct? To the function. Usually, when you think of something as an input, you take it as an input, so you don't change it, you don't modify it, right? And if you want to modify something, you really return it, so it will be a return value, not an int value, right? Not an input value. But C has a way to modify input parameters. The only way you can modify an input parameter inside the function and has this value reflect back on the output is by using this AND. The exact meaning is called pass by reference, which means I'm not really passing the value of the variable, but I'm passing its memory address such that I'm enabling this function to overwrite its value, right? So the simplest meaning is scanf is able to modify num1. Without the AND, it will not be able to modify it, right? So num1 after the scanf should really remain 10 as original, even if the user inputted something different, right? We'll discuss this more later on, pass by reference, pass by value, and how to make use of both. So this will come back again, but that's their meaning for now. Do you always use scanf when accepting inputs from the user? Yes, if you are accepting inputs from the user from the screen, then you have to use scanf. There are other functions, some of them are deprecated, some of them are not, like get character, for example, or get int or whatever. There are also other methods or functions in C if you want to read something from a file, not from a screen. But to read something from the screen, the standard way of doing it is scanf, right? Yes. In the scanf statement, having DDD means that it scans both inputted integers. Exactly, yeah. Scanf, again, is very powerful, similar to printf, that allows you to read a formatted input, and you format it the way you would like, right? Oh, it should never take 2 to 3 minutes for such a program. This should just take seconds. It's not really shouldn't take that, right? This identifier or specifier, again, the one that posted the schedule, we will come into them later on detail. So we have them in one of the slides, so don't worry about this. Okay, so let's quickly go back to the slides. But I'm happy with all these questions. That's good. I guess it's better if we try things out and ask questions and open more questions, even if they come on later, because that means you guys are kind of following what are we doing. Going full screen. Okay. We already said this, every variable has to be declared, all declarations have to appear before the use of the variable, and we have tried on online GDB, if you use a variable without declaration, you get an error. In general, a variable declaration is also a definition of the variable that allocates the memory for the variable. What does it mean? It means, for example, if I'm writing something like int num1 that we have done in our program, when you execute this line, what really the hardware is doing, it goes to the memory. It knows that the type of this variable is int. And again, we have this later on in more detail. If your int is defined as 32 bytes, it goes to the memory and allocates 32 bytes to this variable called num1, right? So it's also a memory allocation for this variable. Good. And based on the type of the variable, well, there are certain rules that has to apply, what operations you can run in this variable, and also how much memory is allocated to the variable. We have went through a detailed explanation of the scanf. Yeah, here's some example of the common identifiers or specifiers. So if you want to input or output an int, then %d is that, character is %c, float is %f, and then double is %f, or if you want it to be a long double, like a double precision, then it has to be LF, right? A long an LF, right? So we have already explained the printf. Yeah, so that's the C development environment. I don't think we have enough time to really cover this in detail. So maybe one thing we have 7 minutes. So let's start at least, right? So we have our hands dirty now on like the first program, different things, and we are kind of like on the C for now, right? Let's first go like one step back and have some theory of understanding of how C really runs, right? In C, you create a program in like a text file, right? And you call it .c. If you open Eclipse, you have a new file and you call it something .c, right? So you have an editor that saves your source code in the disk, right? And then later on, when you try to compile this program in your editor for the lab, for example, is the Eclipse IDE itself, but it can be a text file. And when you run your compiler process, first of all, you go through what we call a preprocessor step. This preprocessor, when you hit build in Eclipse, it goes through all these steps together, right? It first does the preprocessing, then the compiling, and then the linking. Let's jump directly into this thing. So you start from a .c code. You have wrote this in using editor, and then when you hit build in Eclipse, you go through all these steps. The preprocessor, it simply produces also an output.c. It modifies your code a little bit, as we will see in the next slide, but then it's still a C code, right? Then it goes to the compiler. What the compiler does, it takes the C syntax and produces the output assembly code. What is assembly? If you remember from yesterday lecture, we said the interface between the software and the hardware was the ISA, right? Instruction set architecture, right? We said that's the assembly language. If you are using an Intel machine, well, programs are written in x86 assembly. An example of an assembly, for example, you have an add instruction. Say, well, I want to add register 1, register 2, register 3, and then you subtract something. So there are certain assembly instructions with certain defined syntax in this contract. And all ISAs are publicly available. You can download the x86 ISA definition or the ARM one if you would like, right? And I don't think right now in the comp organization second year course you program in assembly, but in past students used to program in assembly. So you will be able to program some microcontrollers writing an assembly code, right? But anyway, the compiler takes a high-level C code and produces an assembly output, the equivalent program, but in .s in assembly. And then the assembler takes an assembly code and produces an output file, .o or object file, which is more close to the machine code, the zeros and ones. It takes the add. It knows from the ISA contract that add is encoded as 011001, and then R1 has this address 1101. So it produces the equivalent zeros and ones encoding of each instruction. But then you might have different files in your program. For example, in Lab 0, we have test files. We have the original function file, which adds 2 numbers. We have header files and .c executable files or source code files. Then there are so many files, and this is the purpose of the linking, is you connect all those files together, right? And then once you do the linking stage, all the .o files will give you a single executable that has your program, right? That's the executable you double click when you run a Chrome or anything else, right? Any kind of program that you use as a consumer. And finally, once you double click this executable, for example, in Windows, you launch it, right? Which means the program will execute, similar to what we hit run on Online GDB or run on Eclipse. What happens is that there is a loader code that is responsible for taking all these zeros and ones and put them in the memory for you, right? To be able to execute them one by one. Good. So that's the high level view of the journey of a program once you write it and until it gets executed by the memory. Let's visualize it a little bit, some more details, and we will conclude with this. So we said the preprocessor is the first stage, and it takes a C code and also produces a C code. So what does it really do? What it does is take the example of the program we have written, which is a very simple one. It makes use of printf and scanf from the studio.h, right? So here, this is our program that we wrote. Single line code, just prints hello. The preprocessor stage goes into your code line by line and replaces any include with the exact code from this include file, right? Because simply, if I don't have printf implemented in include.h, like in this include studio.h, what I can do instead, I really should define printf myself, right? So I should write a code that is called printf, takes some input, does some code, and then return something to me, right? That's the actual implementation of the function called printf. Well, I could have written it myself. I didn't want to reinvent the wheel. This is why I used it from the include.h. But as a compiler, you don't care about this. Any function you use, you have to have an implementation for. So what a preprocessor is doing, it goes to any include file and replaces this line with the code from the include.h, from the studio.h file here. So the outcome of the processor.h will be a much larger program because it will have all the lines of the studio.h or any other include you have in your code. Good. Also, it removes the comments because they don't get executed by the compiler. They are only for human reading purposes. And it replaces any macro names with code. Well, macro names, we'll use them later on. For example, if you have something called define, it replaces it with the actual value, right? But this output code from the preprocessor is still a C code, right? It's just more comprehensive. And then this C code, the output from the preprocessor goes to the compiler. Here is an example of an assembly code that I was talking about. Like you push something into the stack, move something, do an AND and subtract operations. That's called assembly code, right? And then the assembler will take the assembly code and produce the machine code, right? For you, zeros and ones of these instructions. And then the linker, well, you might have different files. Some include libraries, so many other things. You have to combine them in a single executable. That's the function of the linker. It takes all the object files of all your files in your code on your project and then include them in a single executable, right? For example, in Lab 0, again, you'll have so many files in your project, but at the end, you have a single executable. If you double click, it runs, right? And then finally, the loader, when you try to execute this executable, it takes your .exe file or whatever extension for executable you have in your machine, and then it loads all the zeros and ones into the memory such that, well, the CPU will go ahead and read from the memory. Well, this is 00110. I want to read it, and then, well, the CPU will have hardware that knows, well, 001 means an add, and this is really the subject. This last line is the subject of a comp.org course, right? So you learn how the CPU will understand your machine code to be able to execute it as an add, subtract, ALU operations or other type of operations. Good. Questions? So I know that you let me look into. Yeah, we are 1 minute over, but I guess I'm done with this general high level view. Let me see if there are questions. So does the linker take multiple .o files as an input? Yes, Samuel. The linker will take multiple because each file will produce a corresponding .o file, and then, well, you have to have a single executable at the end, which links all these .o files together, right? It knows where is the main, what is calling what, and then it produces a more consistent and coherent single output file. Question was Zuhaib, is there a guide to download the compiler if you have a Mac? Yes, we updated the lab manual to include the detailed documentation for this. If you have downloaded the Lab 0 manual before Wednesday, before yesterday, then please re-download it because we added a detailed explanation for Mac users as well, right? So please recheck that. Question Benjamin. So we are already over time, so you guys are free to leave. Thank you so much for attending, but I will remain for a few minutes to take questions. Is character like a string? Well, that's a very important question, Benjamin. In fact, we have few lectures about strings in C. Character is a string, but it's a single character. Okay, let me see here. Question Arjun, my program compiles if I remove scanf. Scanf this. Yes, this line is written correctly as far as you have num1 and num2 defined, right? So compare yours with the code we have, either in the slides or back in the online GDB. Will the code be uploaded after class? Yes, well, most of the code we write, Adrian, is already has the full implementation in the slides, but I can also upload the source codes that we wrote in online GDB on the class files as well. There is no problem with that. If we already have a GitHub account linked to our personal email, could you use the account for this course as well? Aaron, no, unfortunately, no. And the reason for this is when we do the grading, we do it in an automated way. We have our own test cases. We give you some of the test cases. You write your own. We have ours, but we have a flow where we do the grading for. And this flow is dependent on your Mac ID. So please, even if you have a personal GitHub account, create a GitHub account with your Mac ID. At the very least, well, I will put a list on well, two things you have to do. In Lab 0, you are asked in the README file to add your name and Mac ID. Please make sure you do this because we also grab these for double checking purposes. But also I will create maybe an Excel form on Teams where you guys should go ahead and fill in your, well, that will be publicly available. Let me think of how really to get your, so if you use something different than your Mac ID, you have to email them like the main TA with your GitHub details, because in best offering, what we found, some of you would prefer to use fancy GitHub account names, and we are not able to link them to their own Mac IDs, and hence they don't get lab grades, and this creates a lot of problems for them, right? Follow up. Could we make our Mac email our primary email on our old account? I believe so, Aaron. Yeah, I believe you can change your primary email address in GitHub account, and I have done this before. That's correct. Question: source .u.h is a file that stores the function. Yeah, it stores their implementation, but it's written as without you, so it's stored you like a stdio. But your question is yes. The answer is yes. When I try to compile my code in Eclipse, it says undefined reference to when main 16. Any idea? Well, I guess that's a detailed question that better addressed better on like on an office hour, for example, because we have to go through the exact code. There are no pre-lecture videos for this class, right? So we don't have pre-lecture videos for every lecture. It's just a general for the course itself. What I already posted, you already have last year lectures if you want to watch them before this lecture. So it's not part of this course organization to really have videos for every lecture before the lecture. It's okay if our username is not our Mac ID. Well, if you understood this from what I said, Matt, that's really the wrong take. It's really not okay. You should be using your Mac ID. That's should be 99% of the case. What I was saying is that if there was an obligatory reason why you should keep using your personal GitHub account, please at least change your primary email address in this account to be your Mac ID. Otherwise, we don't have, I would say, an official way to make sure this GitHub account is linked to you, right? So use your Mac ID when you create a GitHub account. If you already have one, please make sure your primary email address is your Mac ID or your Mac email address. Okay, so thanks everyone, and talk to you on Monday then. Yeah. Bye bye.